What is a spacecraft attitude control system, ACS? Imagine trying to keep a spinning top perfectly balanced while it moves through space. That's similar to what a spacecraft's attitude control system does. It keeps the spacecraft pointed exactly where it needs to be. This system is a key part of spacecraft systems training for astronauts because it helps them understand how the spacecraft responds during missions. Whether it's pointing a camera at Earth or aligning antennas for communication, the ACS makes it happen. The system works by using sensors to figure out the spacecraft's current position and direction. These sensors include sun sensors that detect sunlight, star trackers that identify specific stars, magnetometers that measure magnetic fields, and gyroscopes that track movement. All this data helps the system know how the spacecraft is oriented in space. Once it knows the position, the ACS uses actuators to make adjustments. These actuators can be reaction wheels, thrusters, or magnetic torquers. Reaction wheels spin to change orientation, thrusters fire tiny bursts of gas to push the spacecraft, and magnetic torquers use magnetic fields to control movement. The main tasks of the ACS are attitude determination and attitude control. Attitude determination is like figuring out which way you are facing. Attitude control is about making sure you stay facing the right way. These two functions work together in a continuous cycle. The system constantly checks its position, then adjusts as needed to keep the spacecraft stable. For astronauts, understanding this process is vital because they may need to monitor the ACS during maneuvers or even manually override it if necessary. Different spacecraft have different types of ACS. Some use passive systems that relying on natural forces like gravity or magnetic fields to stay stable. But most modern spacecraft, especially those carrying humans, use active systems with powered devices for more precise control. Active systems give astronauts and mission controllers better accuracy and flexibility. Knowing how the ACS works helps astronauts understand how the spacecraft responds to commands and maintains stability. It supports critical tasks like docking with other spacecraft, taking scientific measurements, or maintaining communication with Earth. During training, astronauts learn how to interpret ACS data, respond to alerts, and operate the system manually if needed. In short, the spacecraft attitude control system is like the spacecraft's internal navigation and stabilization team. It keeps the craft properly oriented so it can navigate, communicate, and perform scientific work effectively. For astronauts, mastering the basics of how the ACS functions is an important part of their specialized training. It prepares them to handle real-world situations in space, where precise control of the spacecraft orientation is essential for mission success.